CPM 154 looks like. It looks like that. And then the first thing I do is I paint it with die chem, which is layout dye, and then make it look blue, so if I scratch on it with a carbide scratch, I can see what I'm doing. And I take one of my patterns. You can see my patterns over here. I got some patterns over there. I paint them red if I use them quite often. I take this pattern, or whatever pattern I'm using, and I put it on the steel with the die chem on it, and I clamp it down, and I push pretty hard, and I take the carbide scribe and just scribe around the top, the blade, the handle, the back end, and then it's scribed. Then I take that 6-foot bar and I cut it out, and it looks like this. Using a cutoff wheel, you can see the slag on the side, and I have to remove that and get closer to the lines. You can see the lines are there. So you can see the line is not very close. I do that on purpose so I can be more accurate with a grinder rather than a cutoff wheel. So that's it with the slag on it. Rough cut. Next step is to get rid of that slag, and here I've gotten rid of the slag. It looks a lot smoother on the edges. It won't cut you. And the lines are cut very much closer to what they should be. And also, once I get the slag off and I get really down to the line, I will then set up my grinder to be very accurate at the 90-degree angle from here to there. And then I'll make it, as perfect as I can get it all the way around, because I like to start with as perfect as I can get it, 90-degree everywhere. That's what it looks like with the slag removed. The next step is to square everything off. I want to get everything as accurate as possible, so I set my machine up with right angles and really get them very accurate, and I make the right angle here at all the edges. So I know both sides are the same, and I've done that with this one. So this one's already done, so it's pretty accurate. The next step that I do, and this might be necessary, it might not be, but I like to make it very clean, I surface grind the flats, so they're dead flat. So you can see what it looks like. How it's shiny there, but it's dead flat from top to bottom, from front to back. So now when I grind it, I know that if I mess it up, it's my fault, it's not the blade. The next step after it's surface ground is to put lines, to scribe lines, very accurate lines, where you're going to grind the blade. And because I taper all the tangs of my hunting knives, I also have to put very clear lines on the back end of it, on the tang part. I put lines here, here, and on the blade where I grind it. And these lines are between 20 and 30 thousandths apart. And I use a granite surface plate that keeps it dead flat and dead straight. The next step is to plan the handle holes. You can't drill the handle holes once you harden the steel. You have to plan it out beforehand. So the next step is to take that piece that has scribe lines on it and paint the back end of it with die chem, layout dye, and mark it. I use a caliper to mark it to make clear lines on either side of it so they're very even from top to bottom. And then I take a center punch and I punch over here and I punch in the back. And then I take my caliper again to find out where the middle is, and I just scribe a line there, there, flip it over, there, and then put the center hole right there, and that thing is ready to drill. The next step is drilling it. And that's nothing new, you just drill holes. This is a different pattern, but the holes here are for loveless bolts and for a stainless steel lined thong hole. So the next thing I'll do, I'll show you how I grind a blade, but first I need to put my respirator on because knife making is a dangerous activity, and breathing is one of the fundamental things that we humans do, and I don't want to breathe steel dust for too long. So I put my respirator on, safety glasses, and I'll go start the grind. This grinder is a grinder that was designed and patented and made by Mike Leach. Mike Leach was my teacher in Michigan who showed me how to make knives. He was also a tool maker for GM in Flint. So he had all the abilities and all the tools at hand. So he designed this machine. He's made 7 of them. There's only 7 of them in the world, and I have 1 of them. And to make a knife, you have to have some way to put a grind in the blade. And he said, this is what you have to do. You have to get something to grind a blade, and this is probably one of the better ways to do it for a flat grind. Now this is what it will look like when it gets ground. This is a flat ground blade, and you can see it right here. It's flat ground on both sides. The next step is to taper the tang. So what I'm going to do is first cut down to the lines here that I've scribed, 30 thousandths inches apart. I'll just make a little cut there, and then I'll go ahead and hollow grind both sides, and then taper it from there. Next thing we'll do is to sand these coarse scratches off, because I don't want to have a hardened steel blade with that coarse scratching, and it's hard to get the scratches out of a hard blade. Much easier now. And I'll sand it at 320 grit on this flat wheel that was made on the GM brake lathe. So what I'm trying to do, these scratches here are 120 grit scratches. They're pretty coarse. I want to take those out, and I also want to flatten this part over here, take those scratches out. So I have the scratches out on this flat part here. Now I'm trying to take out the scratches on the blade itself and replace the 120 grit scratches with 320 grit scratches. And also make the plunge cut a little bit smoother, because it gets pretty square on the machine over there, and I round it off a little bit. So the scratches are now out, and it's kind of warm there, so I'm not going to touch it, but it's ready for heat treat. So I will take this 309 stainless steel foil, and I've already pre-cut it to 12 inches by 6 inches. It comes in 50-foot rolls, 3 feet long, And you take the steel that you want to put in there. This is a knife that's been ground, taper tanged, holes drilled, blades sanded, and the holes chamfered so they don't crack in the heat treat. But also you put in a piece of brown paper. It doesn't matter if it's brown or white, it doesn't matter, but you put it in there. So when you heat it up to the temperature, this will be sealed, and the burning, consuming that, sucks the oxygen out of there. And that'll burn at much lower temperature than the quenching is. I'll start wrapping this up, and what I do is I just do this. I fold it, and I also mark it. I want to mark what steel it is so I don't get it messed up. And I also I put an arrow on here so I know which goes in first. Because when it gets hot enough to quench, the steel gets almost fluid, it gets soft. If you grab it by the point, you can bend it real easily. So the back end is here. I always put it in point first, so the pinchers that I take it out of will grab the back end, which is thicker. Anyway, that's what it looks like. And then I fold it up, and here's where you have to be careful because this stuff is so sharp, it will cut you a good one. That's double sealed on that end, on that side. And this packet is now ready to go into the furnace. And this is my furnace. It's an even heat oven made in Michigan. And it has places inside to put 6 or 7 blades. So they're vertical, so the heat acts on the steel evenly. So here's the arrow. I know where the point is. It goes in this way. So the thickest part of the blade, when it's so hot, it'll be almost fluid. I will grab that and it won't bend the point. There's that. Okay, here's the numbers. I turn it on. This is a computer-controlled furnace, and it has 4 sets. I'm using the first set. There's 2 segments to this heat treat. I ramp full on the first segment. I ramp full to 1450 degrees, and I will hold it for 7 minutes while it equalizes in temperature. And then it'll ramp full up to 1950 degrees, which is the austenizing temperature. That's the quenching temperature. And we'll hold that for 25 minutes. And it's ready and it's on. Time to take the blade out of the oven and quench it. So I take the tongs and I take it out and I make sure to hold that blade vertically. If you tip it sideways, it's so soft that it will bend. So you hold it vertically, you take it out and you set it on the plate, the aluminum plate vertically, and then you flip it down sideways. So it's always touching the spine of the blade. And then you put the other aluminum plate on top of it and put some tension on it, let it cool, and you can feel the plates are warm. So the blade's getting cool nicely. Still warm, not bad. Here's what it looks like when it comes out, all those colors. Now what I do is I will take my Rockwell hardness tester, Ames hardness tester, and what it does is it will measure the distance that this diamond penetrator goes into the steel at 150 kilogram pressure. So I put it on there. I'm finding a good flat spot. I put it in there. I get it right to a set mark, which is 0, right there. I move this wheel to the acrylic, and then I put the 150 kilogram force on it. There's 150 kilograms. Now I back it off, back to the set mark, to the 0 mark, and I read directly. It's right on 60. A lot of factory knives are 55. Custom knives are usually 60, 62. Some steels can go 62, but files are usually about 59 or 60, so this will not be cut by a file. It will skate right over it. Now I will quench this in liquid nitrogen, and I let that soak for overnight, and I expect the numbers to go up maybe 2. So this is right now 60. Hopefully when it gets done cryogenically being treated, it will be about 62. It completes the austenite to the martensite transformation, and it does all kinds of other good things. Stress relieves it, and grain structure, the whole thing. It benefits the steel in many ways. And there it is. So now it comes from the cryo, and I temper them twice. Every knife has to be tempered twice to make them not brittle, to make them resilient, to make them tough, to make them wear resistant. And I temper each of them twice for 2 hours. After that, it's time to polish it. Here's what it looks like when I start off, when it comes from all the tempering and the cryo and the whole quenching thing. And I'll show you what it looks like when I get it polished up a little bit. So there it is at 320 grit. Now what I typically do is I'll go to 600 grit. And there it is to 600 grit. You might not be able to see much of a difference, but there is. I go back to 400 grit, and I go this way to make sure all the scratches at 320 grit are gone. And then I go to 600 again, and then I go to 800, and then I go to 1,000. I want to make sure all the scratches are this way. And then I buff it. Next thing is to polish this with a flat block. I always sand with a block. So you keep things flat. And I go back, this is 600 grit now. I go back to 400 grit to make sure there's nothing in there that's going to surprise me later on. And this probably takes more time than anything in knife making. If you want to make a highly polished knife, this is how to do it. And you just have to sand it and look and be honest with the the scratches that you see in there. Sometimes I wish them gone so I don't see them. They'll come and bite you later on, guarantee. As soon as you get to the next finer grit, they're there. The next step would be to take 600 grit. And okay, so I'm making everything go this way because I'm taking more of the scratches out, and this is more of an inspection thing. 600 grit would be then this way. 800 grit would be then this way, 90 degrees to what you just did. 1000 grit would be this way. Again, so you can see exactly what you're doing. If you go parallel, you can't really tell anything. But if you go opposite, you can tell everything. Well, this is a completed knife right here. And you can see that it starts out in this piece of steel. And we grind it, we drill it, we plan it, shape it, heat treat it, polish it, put a handle on it. And this one has bolsters on it. These are stainless steel bolsters. And it has loveless bolts on it, which are basically brass nuts and a stainless steel screw. So this handle is glued on there, but it's also mechanically held on with those bolts. Tapered tang and the red line spacer that Bob Loveless so loved. Bob Loveless was one of the premier knife makers in the world. He lived in California for many years, and he championed the use of high alloy stainless steels. This is actually a copy of Bob Loveless' improved model. It doesn't have a guard that sticks out much, but it has this curve here and it has this finger groove right here, and it feels really good in the hand. When I make a knife, I try to first pick the best steel I can possibly find on the planet, and I try to heat treat it the very best I can. And then when I grind it, I try to make every line as exact as I can. I try to make the plunge cuts absolutely even. And when I put the handles on, I try to make the fit perfect. And I try to make the handles, whether they're wood, antler, or micarta, I want those handles to last a long time with heavy abuse. So I try to treat them with stabilization and super glue. And I like to see my knives in the field being used, and roughly.
Thank you for watching. Join us again on Common Ground. If you have an idea for Common Ground in North Central Minnesota, email us at legacy@lptv.org or call 218-333-3014. To watch Common Ground online, visit lptv.org.